In this video, we'll be looking at a linear program called the transportation problem. You'll want to make sure that you have installed your solver add-in, so you might want to stop and do that if you do not have it available. Alright, in this problem here, we have a situation where we have books being shipped between warehouses and bookstores. So over in the text box, this book, Adventures in Analytics, has been ordered by university bookstores in Boston, Cincinnati, and Atlanta, and we have the order numbers. And it's warehouse in Cleveland and Detroit with limited copies. The shipping costs you'll find over here in the table, and we want to figure out how many books should be shipped from the warehouses to the bookstores that would minimize the shipping cost. Alright, now when we do a linear program, the very first step is always to define your variables. And as you'll see, a very convenient way will be to use a version of this shipping table. This one showing the costs. So let's copy this and paste it. Now, the table is of shipping costs is very easy to read. We see that Cleveland is shipped to Boston, Cincinnati, and Atlanta, and we give the price per book. Same thing, Detroit ships to these three cities. So notice there are really a total of 3 and 3 6 shipping routes. So if in the table that I copied here, if I were to go and delete all those numbers, I could use these same 6 cells to basically represent or hold my variables. So for instance, this cell right here, that would hold the number of books being shipped between Cleveland and Cincinnati. Now currently they're all 0 because we don't know the solution. But in other words, when we finish this problem, that's where our answers will be located. Alright, so that was pretty simple. The second thing to do always is to define your objective function, and that's what you want to maximize or minimize. And we know from this problem that would be the shipping cost, total shipping cost. Now what I'll do is I'll go and I'll put the formula for shipping costs just to the right here. Now I want you to think about logically where we would get that total shipping cost. It would be the cost of books shipped on each of these routes, each of these 6 routes. So we would take, say from Cleveland to Boston, we would take the $1.72 and we'd multiply it by however many books were shipped across that route. So for example, if this were equal to 100, if it turned out that we shipped 100 books from Cleveland to Boston, we'd want to take that 100 times that $1.72, which would give $172. So we'd want to do that also for each of these other 6 cells. It would be multiplied times the corresponding cell up above. So one way you could do it would be to work out the 6 separate multiplications and add them all together, but fortunately the sum product formula can handle this situation quite easily. So I'll grab the sum product, and all you have to do is select all 6 shipping costs and then go and select all 6 of your variables, and this function will do all the 6 separate multiplications and it'll add them together to give a grand total shipping cost. Now why is it 0? Because currently we aren't shipping any books. Let's just randomly pick one of these cells. How about Detroit to Cincinnati? And put 100 in there. Let's make sure the shipping cost updates appropriately. I hit enter. Well, is that right? 233, 100 books at $2.33 a piece. Sure enough, it updated properly. So it's not a bad idea to test things that way. Now I can go back and zero it back out now that I've tested it. Alright, now there we go. So the third thing after you do the objective function now is to set up our constraints. And constraints can be requirements or limitations. Well, we see that the bookstores have requirements. They want a certain number of books, whereas the warehouses have certain limitations. Cleveland can't accept an order for more than 1,000 copies because it simply doesn't have more. And same corresponding idea with Detroit. So we're going to have 3 constraints dealing with the orders and 2 constraints dealing with the warehouses. All right, well, how will we do that? Well, if you've watched my other videos for linear programming, you know that I like to always set things up with the left-hand side, the type, and then the right-hand side. I'm going to center things a little bit. So let's have a look first at the orders. Let's look at Boston's orders. Boston has ordered books. We know that they've ordered 300 books. So the right-hand side would be 300. Now for the type. Well, if they get fewer than 300, they'll be unhappy, and there's no need for them to get more than 300. And so this would be an equal to constraint. I don't want to type on the keyboard the equal symbol because it'll think I'm constructing a formula. So I'm going to spell this one just out as a word. Now for the left-hand side. This will be a formula. Many linear programs use a sum product for the left-hand side. Be cautious. This one will not. Look back up at this middle table. Where is Boston getting its orders? Well, it's getting orders from Cleveland, which would be this cell, and it's getting orders from Detroit, which will be this cell. So basically, all we want to do is add these 2 cells here. We could just click on the one, do a plus sign, then click on the other. That would be inconvenient, though, if we had a list of 100 warehouses. So instead of clicking, I'm going to do the sum function, which just adds things up. So add up these 2 orders, and that'll tell you how many books Boston will get. Close the parenthesis, hit enter. Now it's 0. Let's test our logic. Suppose Boston gets 200 books from Cleveland and 100 books from Detroit. Then see, this is saying Boston would get 300 books, 200 plus 100. Looks good. So let's continue with our logic. Cincinnati has a book order. And their book order is for 560 books. And just like Boston, they don't need more. They need exactly 560. And so looking at the table, we're going to add some things up. We're going to use a sum. Cincinnati gets its orders from Cleveland and from Detroit. So just add those 2 up. And if you're following me, you should be able to do the third one, the Atlanta order, on your own. Atlanta gets books. We're going to sum. Atlanta gets books here from Cleveland and Detroit also. Do that. They want exactly a certain number of books. And what do they want? They want exactly 625. So fantastic. We have our 3 constraints that will help satisfy the orders from these 3 bookstores. But we have other constraints also. We do have these limitations from the 2 warehouses. We need to incorporate those because we don't want Cleveland to try to send out 1,200 books when it won't have that many. So let's do the warehouses now. I'll skip a line just to help separate them here. So we got our Cleveland, what should we call this? Well, they have 1,000 copies, so we might want to call that capacity. I can get my spelling right here. Cleveland capacity. So Cleveland has a capacity of 1,000 copies, but be careful when you go to consider the type. They can send out fewer, they can send up to 1,000, they can't send more. So this would be a less than or equal to type. And let's figure out how we'll get the left-hand side. Now Cleveland sends out books to Boston, Cincinnati, and Atlanta. So when I'm looking at this row here, those 3 orders need to be less than or equal to 1,000. So again, I'll just use my sum, and I'll add together those 3 orders. And finally, all we have to do is construct the one for Detroit. Detroit capacity. Detroit has a capacity of 700 books. They have to stay within that. And we will add up the orders that are leaving from the Detroit warehouse by looking at Detroit and saying orders will go to these 3 locations. And there we are. So notice how it really made it easy to use this grid here to represent our variables, because we were just able to look down and look across in order to get our appropriate sums. All right, well, we should be in pretty good shape here. Let's keep our fingers crossed. Let's go to Solver. I will click the Data tab, and I will come over here and I will click the Solver tab. Let's see what it says. Objective shell. Okay, I'm not sure. That's probably from the last time I used it. So I'm just going to delete everything. All right, set your objective. Objective is the shipping cost. Make sure you change it to min. No one wants to maximize shipping cost. So minimize your cost. Variable cells, we've used those all along. Those are those 6 cells here. You grab them as a block. And now for constraints. So we click in here. We want to add a constraint. Now we could add all 5 of them separately, but when you have several in a row that have the same type, you can save time by doing them as a group. So all 3 of these equals, I'll select, see here, all 3 of the left-hand sides. Over here, I will select all 3 of the right-hand sides, and then since they're all the same, I can just select the equal symbol for the type. Okay, I got 3 of them. Let's go get the other 2. Left-hand side, less than or equal to is good. Right-hand side, looks good. We've done everything, so we can say OK. Want to make sure that this box here is checked. We can't ship a negative number of books. Make sure you're on Simplex LP. Click Solve. Okay, now let me drag my dialog box over here. It says Solver found a solution. All constraints and optimality conditions are satisfied, which is what you want to see here. So we can just say OK. And let's see, our shipping cost is $28.19.75. That's in dollars. And you can look at the variable table now to see how many books are shipped along each route. So Cleveland is shipping to Boston and Cincinnati, but nothing to Atlanta. Detroit's only shipping to Atlanta. So we got this mix here. Something that can be helpful, look down here in these constraints. Here 300 is the same as 300, same thing with the next and the next line. We would say that these constraints are binding. Left hand equals the right hand side. But let's look at the Cleveland and Detroit capacity statements. Cleveland had 1,000 books. They sent out 860. So that's non-binding. And what we would say is there's a slack. Do the arithmetic, you see there's a slack of 140 books. In other words, left over at Cleveland. Detroit only sent out 625 of their 700, so that is also non-binding. 700 minus 625 is 75, so there's 75 slack. Identifying where you have slack can be useful if you want to tweak things or want to accommodate future orders. All right. Well, I hope this has been helpful to you. I'm going to sign out now. Good luck.